Next up, we've got David Freedman from Claranet to talk about securing BGP. And I think the question again is, why? Perhaps why not?
Why not indeed? Okay, well, thank you everybody. And the title of this talk is Securing BGP, Why Not? And I'm going to talk about two things. The first of which is an ITF draft called OPSEC BGP Security. And the second of which is a bit more of a mouthful, CCRSR/MANRS, or the manifesto. You'll find out all about this when I get to those slides in the talk. So let's get started. Before I start, actually, I'm going to talk about some aspects of securing bits of BGP, including the session. But I just want to say a few words about why that's important. At some point in the 1950s, copper subsea cables were signalled on a mixture of VHF or VF tones. And at some point, I think in the 1970s, there was a signalling system that the telephone networks would use to go and seize and dispose of trunks that had evolved from this. It was called CCITT5, and it was replaced with CCITT6 and 7. It was known as SS6 and SS7. But the important thing about SS5 was that if you knew the tones, you could control the network because it was signalled in band. And many people in the US did. There was this thing called a blue box, and you made a phone call to somebody abroad, and when they'd hung up, you'd play a combination of two tones, I think it was 2400 and 2600 hertz, and you'd seize the trunk, control it, and get it, continue using it without being billed for anything. So this is an example of in-band signaling, and BGP, I would say, is a bit like this. A BGP session exists over the same network. We don't have a dedicated out-of-band signaling network like SS6 and SS7 introduced. What we've effectively got is two TCP peers communicating with each other, and the very packets that forwarded past these routers, expose them to segments being sent directly from end users. So we've got this in-band signal network. It's worked fine for us so far, but if I can disrupt these sessions, I can cause you some pain. If I can hijack them, I can cause you some more. So let's talk about this draft. It is a draft. It's not a standard. It's going for a BCP, and it's part of the Operational Security Working Group, and it concerns BGP security. And it's written by vendors and operators, but it's mainly for the use of operators. Hopefully, it's just at last call at the moment, and if it gets ratified, it might end up being BCP 192. I'm just guessing that because they've just assigned BCP 191. It covers 5 topics: session protection, control plane, flap dampening, prefix and attribute filtering, and I'm going to talk about each of these now. There are obviously many overlapping documents. Right Routing Group produced quite a few. There are the BCOPs that Chris spoke of, industry fora presentations, CCRSR and MANRS, which I'll talk about, and vendor recommendations, and all of these people, it's great to know, have been consulted to avoid conflicting information. The document's had quite extensive review and has been around for some time now. So control plane. Before I start with this, how many of you are familiar with the concept of infrastructure ACLs? Put your hands up. Yeah, quite a few hands, thank you. So an infrastructure ACL is effectively an ACL that you put at the edge of your network to prevent packets from reaching parts of your critical infrastructure. You see, if you've got all of these routers speaking BGP, even if it's just iBGP, there isn't much incentive to have random things out on the internet talking to those TCP ports. So it's quite common to go and put all of your infrastructure in a single set of networks that you can then filter on the edge because nothing should really be talking to it. Now, that's quite a crude approach. Of course, there are always things that need to get back to routers. They're usually ICMP related, and that's why we've got control plane policing. Control plane policing is, for those of you who don't know it, a way of controlling or policing the traffic that comes into the control plane to stop routers falling over. I've got a point here. It's worth noting that a lack of good control plane policing used to be responsible for many operators shutting down their peering points when there's an event on the exchange, because of course all that layer 2 traffic ends up getting punted to the CPU, and off you go, the router falls over, and then it keeps falling over, and you never converge. So an RFC was published in 2011, RFC 6192, and as a result of that, vendors have adopted some of the recommendations it made. Control plane policing used to be quite an art. You have to navigate through all of the, where's my control plane receiving traffic from? I have to know about my DNS servers, I have to know about my NTP servers, my TACX servers. I'm running ISIS and I've got a box that can't deal with this. But I'm pleased to say actually that I recently procured some kit, and out of the box it had a really good set of defaults, so much so that I really didn't have to tune much. And the fact that vendors have adopted it and that there's a standard that now describes it makes it a lot easier for people in this day and age to work with. I must say there's a lot of new kit now being shipped where the nightmare of having to plan your control plane policing is quite reduced because of the sensible vendor defaults. So that's the control plane, IACLs and COP. Then there's the session protection. There's not really much to say about MD5 in that it's a particularly weak thing. So what's MD5? What do I mean when I say MD5? Well, if you're sitting there receiving TCP segments on the network, that segment could contain an RST purporting to be from your peer. So there was quite a flurry around the mid-2000s of, well, is there any way we can authenticate it? And the best thing that people could come up with or implement at the time was for one party to hash the TCP packet. I must actually point out this is not a BGP protection mechanism, it's purely TCP. So one party would hash it and the other person knowing the key would be able to confirm that the other party sent it. It's actually pretty weak. Many of the vendors that implemented it didn't implement it properly or in the right order. These days it can be used as you can exhaust the resources on the router. They can be attacked by just sending loads of different MD5 hashes and asking the router to compute them. So it's actually really not a great idea. We stopped mandating it some time ago. It's been replaced by GCSM, which is a neat little trick where if you're directly connected to the peer, you can rely on the time to live field in the IP packet to ensure that it actually came from a connected hop. But then again, you're relying on all the infrastructure in the middle decrementing that TTL. So it's not a way of authenticating the peer per se, but it's a reasonably good mechanism to ensure that the peer is at least an IP hop away from you. But what's actually been recommended now is something called TCP/IO, which is standardized TCP, I think, authentication option it stands for. It's a newer kind of way of looking at the issue of identifying the TCP peer. It is much like IPsec in that it mandates a number of different means of doing the authentication. IPsec's a full suite of you can either encrypt or authenticate. TCP/IO is a very simple, lightweight mechanism for doing the authentication, and it's become the preferred mechanism in this draft, at least, for authenticating the TCP peer. And an important thing to say as well is obviously, if you can block your own address space and ingress, that's good. Some of you might design your networks to have breaks in the middle of them, so parts of your IP space ending up meeting back with you around the front. That's fine as well, but if you don't do that, you shouldn't be accepting your own IP space. There's no good reason for that, and that's just, it will leave you open to things impersonating IBGP peers. It's not great. So prefix filtering, well, you can filter bogons. It's really nice that in this day and age we can have these published in a place that stays the same and is fixed. I now actually have a machine-readable version of this you can go and look at. There's not much to say about bogons other than the not allocated for IPv4 is notably missing since all of IPv4 has been, well, allocated. Take a feed of them. I think the not allocated is still quite important for V6 because there's quite a lot of V6 out there which isn't allocated, in fact, most of it. So do filter that. Maximum prefix on peers and upstreams. You don't fall into the trap of saying my transit provider I trust implicitly. Everything that comes from the top is good. When you start reaching 4 million prefixes, you'll find it's not so good, and it'll fall over. Filter to specific because that's a policy that everybody adopts, and if you don't need to change it, then just do the same as everybody else. Filter your own prefixes, I just said, and filter the IXP LAN prefix as well if they want you to. One of the good things these days is that IXPs don't have their address space or have a policy that their address space isn't announced. In fact, actually I can think of many IXPs that had this policy for a long time but nobody was actually doing it. If they say, well, don't announce our address space on the network because then people can't reach it unless it comes through us, And if we can control how traffic comes into the IXP LAN from the outside, then we can filter. We can basically throw away most of the traffic and only accept the important stuff like ICMP. So if the IXP wants you to filter the LAN, filter the LAN. There's also URPF as well. If you can use loose RPF on the edge, it's great because anything which doesn't exist or has a null root, when you receive it, you can throw it away almost instantly. And on many pieces of hardware that you get out there, that'll be done in hardware. It's also a really good technique for mitigating attacks that come from known sources because, of course, you can stick a /32 in your routing table pointing to a discard address, and the ingress interface will happily throw that away with loose URPF because, of course, the adjacency or whatever it represents in the forwarding table doesn't really exist, so keep throwing it away on the edge. And there's a note also in the draft about side origin validation. Mixed opinions about this. I've now got routers that do it. Not quite sure whether I want to be doing the validation yet, but the draft does speak quite a bit about the situations where mechanisms you can take to treat unvalidated objects and what you would do with them. And I think the summary of that is that you don't just drop them, you depreference them over other things. But I will say, if you've got an option to create rowers and sign them, do that. The YPNCC produced this great tool where they'll host the validator for you, and they'll pretty much do the signing through a web interface, and it's not much effort. So get your rowers signed at least, so that people out there that want to do the validation can at least help them out. Then there's flap dampening. In 1998 we thought this was a good thing. Then in 2006 we thought it was a bad thing. And now we think it's a good thing again. It's been re-standardized with some adjustments to timers. The RIPE community also agree with the IETF and think it's a good thing, and a RIPE document was published on it. I think let's all agree it's a good thing, again, with these new timers, and follow both the RFC and RIPE. I'm hoping that, like the control plane, the vendors are going to go and put sensible defaults in so we don't have to sit there and try and implement what are being considered best current practices into router configuration all the time, because this stuff can get out of date. So I think this RFC of 7196, I think it's called usable flap dampening, because it does actually make it usable by removing quite a lot of the algorithms. I don't know if you remember, but RIPE had this concept of graded flap dampening, where you would dampen at different, you'd give different penalties to different lengths of prefixes, and then you'd prioritize the root name servers because they were obviously special, but then you deprioritize other things. So the usable flap dampening, we've seen it come back, and it's now being accepted as a good thing. So yeah, if you can do it, if you can implement the suggestions in there, great, but again, I'd wait for the vendors to move if you can. If you've just turned it off, you're probably not missing much. Then there's attribute filtering, there's AS path filtering. Try not to accept your own AS in the path. I know lots of you that with VPN networks do this all the time, because you've got customers that want to use the same AS inside L3 VPNs many times over. Try not to do this on the edge. Maybe you've got the split network scenario described where you don't have one day you might not have a backbone in the middle, and you want to come back around the top and get to yourself again, fine. But for most of you, you don't need to do this. Don't accept it. Next hop filtering as well. If your box can do this, great. You should do it. Why would you accept an update from a peer where the next hop wasn't in your control? It may be the case that you're rewriting that next hop back into your IBGP. But if you've got a box that's connected to multiple peers, somebody sends you an update with the next hop of another peer, it's likely this traffic will just come into the box and then trombone out, and it's outside of your control, and it's possibly a policy violation on your part. So, be very careful about what you accept as a next hop if you can filter it. But be aware of the RTBH. Some people do this genuinely because they want the traffic dropped. You should only really do that if you've got an agreement with them. And in that case, those are the only situations I would imagine one would want to change the next hop. And also communities. Don't accept communities unless you've got a policy of accepting communities for engineering purposes from third parties, whether they be customers or peers. I would also say, although it's not in scope of this draft, the same with forwarding. If you want to stomp on top of any DSCPs or anything that you receive in the forwarding path from people that shouldn't be there, that's also great. It's not in the scope of this BGP document, though. So for the draft, what's next? It was in last call for BCP as of yesterday. It's open for what they call substantive comments, i.e. things which would be major to the document. Go and have a look on the OPSEC mailing list, or mail the authors directly if you've got something to say about it. I'm just sitting there hoping that the vendors who have been involved in the document and said, yes, we're going to do something about it, actually go and implement these defaults so we don't have to worry about continually reviewing this practice all of the time. Most of us want easy lives, and if vendors are all in agreement with these practices, we're going to get that. Now I want to talk to you about this CCRSR MANRS business. So originally there was this thing called the Code of Conduct for Routing Security and Resilience, that's CCRSR, but it's now called Collective Responsibility and Collaboration for Routing Resilience and Security, or CRC-RRS. It's originally a group of large operators that got together and proposed a code to follow to clean up issues with poor filtering, routing and forwarding hygiene. And it now uses ISOC as a neutral platform, as a convener and a promoter. It's now called, the output of it's now called MANRS, the Mutually Agreed Norms for Routing Security. And there's a document which explains our objectives. And the objectives are to raise awareness and encourage actions by demonstrating commitment of the growing group of supporters, to demonstrate industry ability to address complex issues, and to have a clear and tangible message: we do this and we expect you to do the same. But what is this? It's really three actions: to prevent propagation of incorrect routing information, to prevent the egress of traffic with spoofed source IP addresses, and to facilitate global operational communication and coordination between network operators. So it's a set of very sensible principles, but the important point behind it is that we're raising the awareness of them, but we're also demonstrating our ability to buy into these and actually execute on them. And I think it's a very important thing, and that's why it's referred to as a manifesto. You can actually see a copy of this at routingmanifesto.org. It's been many, many months of work, and we've had lots and lots of feedback through mailing lists, and also on the site you'll see that we've made sure that all the feedback we've had is posted publicly. We're now at the point where we're pretty much through most of the comments, and we're asking operators to sign up to the principles in the document. Hopefully there's going to be minimal effort versus gain. It's a positive PR exercise for your network. Most of this stuff you're already doing just should be about promoting it. I would like to say this is something you could all easily sign up to. So can I have a show of hands for networks that would be interested or capable of signing up to this? 1, 2, 3, 4, 5, 6. That's not bad. 7. Well, that's it for me. So if there are any questions, please go ahead. Go and have a look at the manifesto site, routingmanifesto.org. Nick.
Right. As a root server operator, I have a small amount of data on nextop not equals peer IP address. And it turns out that this is actually a little bit more subtle than it looks, because the BGP RFC says that if you're on a particular shared layer 2 domain, you are entitled to announce a prefix with the next hop address of any IP address within that address range, which is fine. And there are many valid situations where this can happen. One of those situations is where you've got 3 peers, A, B, and C. A and B, A is providing transit to B, but B is also peering, and both A and B are connecting to, are peering with C. And in that case, A will announce the next hop to B's prefixes of 2C. You need to see this on a diagram.
I can visualize it. Yeah. I think my response to that would be, firstly, what's the IXP's policy on this? So what do you actually want to happen on the exchange? Are you happy with this behavior?
We forward layer 2 packets.
Okay. Well, let me put it another way. Do you see it as being acceptable behavior between members to advertise an X-top that belongs to them or doesn't belong to them?
If they have a legitimate reason for advertising next tops like that, then we can certainly do it. Bird has some really powerful features so that you can actually see what's going on with BGP updates. And there are situations where you have, say, bilateral peering. Yeah, absolutely. If you have a bilateral peering with another organization, you should absolutely stomp all over the next hop and just rewrite it to be whatever the peer address is. Because if your peer is not sending you the peer address that you think you're getting, well, then there could be a problem. And even if they're saying, well, actually the traffic should go over there, well, maybe it should, So it's a difficult issue.
I think I would say to that, if the IXP policy is permissive of it, then you can permit it. But then I would say you don't want to be in the situation where you're being sent an update with the next hop of something that's not on that LAN, but is connected to your router. Say another peering exchange.
You can't do that with BGP. It has to be the exchange IP address, because otherwise then there's a protocol error and the remote side will reject that next hop. That's the case with eBGP anyway.
I believe the validation is done locally by the box, and there are cases, I think, inside L3 VPN where that next hop validation isn't processed in the same way. Because you have remote and recursive next hops if they're reachable through that interface.
I can't answer that question. It's certainly a protocol violation if you have just a standard IPv4 unicast AFI-SAFI connection to an eBGP peer, that it has to be on the same LAN. And if it's not, then it should be rejected by the remote side. Whether it is or not, yeah, absolutely. It's up to the implementation.
And I asked a second question related to this. Do you see members advertising themselves as a next hop, accepting the traffic, not accepting the traffic, but issuing ICMP redirects to another peer address that they own?
We have seen that occasionally, yeah, we have seen that.
Do you think, is that acceptable behaviour on the LAN?
That's a good question. It's certainly something that's going to break. And it's something that probably will happen if or at least something that may happen if the organization that's issuing the ICMP redirects is being sensible about their next hops. It's more likely to happen if they're more sensible about their next hops.
Okay,
so this is why I say it's a slightly more subtle. It's a more subtle problem than it looks at first sight. There's what you call an internet draft in last ITF last call at the moment, BGP root server operations, which actually explains.
Yours, is it?
Yeah, it is. Yeah, sorry, minor plug, but it explains also a traffic stealing problem that you can run into if you don't rewrite the next hop. So it's a difficult area. There are reasons why you might want to rewrite the next hop. There are other reasons relating to ICMP redirects that you mightn't want to do it for specific prefixes. So tread carefully, because you can break stuff easily.
Okay, thank you. Any further questions? No? Well, thank you very much, everyone.